Welcome to Mathematics with Tom. I am Tom. And in this video, we're going to look at linear combinations when we move into 3 space, or into R3. So here we go. So this is linear combinations linear combinations in R3. Now, there's something interesting here. In our last videos, we said that the vector x was 2, 1. And we said that the vector y is 1 minus 1. Now, because x and y both have 1, 2 components, these vectors, both of them, are in R2. But the title is about R3. So let's take these vectors, x and y, and let's keep them in the xy plane, but now we're going to put that into R3. So how would that change? So I still want my 2 and my 1. I want my y to be 1 and minus 1. But I'm going to change them so that they're in R3, and I'm going to call it x prime, to note that I'm making it still based on this x, but it's being changed. How is it being changed? Well, we saw earlier that the xy plane in R3 has z equals 0. So now x prime is 2, 1, 0, and we have y is 1 minus 1, 0. Y prime. Just to note, it's based on y, but it's a different y. Okay, these now we have x prime and y prime, and these are in R3. Now, first thing I want to do is, I think it's good practice to be able to see these in 3 space. So we're going to graph these, just like we practiced. So here we go. I'm going to start with my vertical line. This will be my z-axis, make my horizontal line. Be my y-axis, and then let's bring out our slanted line for our x. And let's kind of mark these off here in segments, so make them a little bit bigger. That? How about that? That looks about right. 2, 1, 2. Okay. So then I have that and that. Okay, there we go. So now remember this, and I'm going to, hopefully this helps. If not, we'll fix it. Remember that the xy plane is when z is 0. So I'm going to color this in purple for a moment. I'm going to kind of smudge it a bit, because this purple region here, this purple region is the xy plane. So when we're in here, you're graphing just like you would have when you first learned on a very simple Cartesian coordinate in 2 dimensions. So when I'm here, the vector x prime 2, 1, 0 means you go out 1, 2 units in the x direction, and then you move 1 direction in the y. 0 is fixed, and there's your vector x. Okay, there's my vector x. Now, the vector y is a little bit more challenging to draw. I'm going to come out to the left with some big heavy dashes to show you that really these are behind the board. So we have to think through this, but that's not a problem. So to graph y, I would need 1 minus 1, 0. So x is 1, so I come out to 1. Y is negative 1, so then I come back this direction to the left. Come back to the left, and right there, that is my vector y prime. So, oops, this is x prime, this is y prime, and this region here is also purple, so I'll give it a little purple hue just to help us see that the purple is the xy plane. You don't say it's R2 though, because R2 only has 2 components. We're in R3, so you just refer to this now as the xy plane in R3. Okay, so now let's take a look, because we have a problem, and I'll show you what it is. I would like to somehow leave the xy plane behind and move into greater heights. But I want to show you that I can't do that. And I think the best way is not visually, but to prove it with our mathematics. So if I take some scalar c, and I multiply it by x prime, and then I take my scalar d, and I multiply it by y prime, well, we're going to do this a little bit more quickly here. If I take c times 2, that would be 2c. If I take c times 1, I get 1c. And then the last one now here is the important part. If I take c times 0, what do I get? I get 0. Plus, I have d times y prime, so that's going to be 1d. Repeating this, I have 1d. I have minus 1d. And then the final one is 0 times d, but that's just 0. Well, if I add those together, I have 2c plus 1d. I have 1c plus, 1c minus a d, but my last coordinate is still 0. So, wait a minute. What does that tell us? It tells us this. It tells us that if we only have x prime and y prime, we are stuck in the xy plane. Somehow, the only way to get out of the xy plane is to have a vector that has some z component other than 0. So that's the big key here. This says we're stuck in xy plane. Stuck in xy plane. Let's see, to move off the xy plane, a third vector is necessary. A third vector with a non-zero z component is necessary. Okay. So I'm going to just make one up. How about that? So let's try a third vector. We've used that x and y. How about we use v? Let's use v for vector. It seems fitting. Let's try x is 0. Let's give it a y piece. How about that? And let's put it up there into the z's. So that's my vector now, v. And let's go over here and draw. Let's draw the vector v. So the vector v says that I am at 0, 1, 2. So x is 0. So there's no movement on my x-axis, 0. Y is 1, that's here. And z is 2. Well, that's going to put this vector all the way up here. Now, not only that, let me see if I can connect that vector. straight line. So there's my vector v. Okay, and where is v? V is in this region. I'm going to just shade this because this is important, and we saw this earlier, that what was so special about this is that x is always 0. And we said that when your x is always 0, you're now stuck. Where are you stuck? You're stuck in the YZ plane. So this is my YZ plane. Okay. So here it is. I want to show you now that even though V is stuck in the YZ plane, X and Y are stuck in the XY plane, we can now pick up any other vector in R3. And the way we do that is a linear combination. So this is where it all comes together. Oh, and you're not going to like this, but I have to share it with you anyway. We used the scalar c. We used the scalar d. It seems logical that the next scalar would be e. And we're not, this is going to just be the letter E, it's not the number E. But we could use F, but I don't know. I just like the pattern, C, D, E. So let's do that. Let's say this. Let E be a scalar. This is not the number, this is the scalar. So let's try this. So if I take C times X prime, and I add to that D times Y prime, plus E times the vector V, well, we've already figured out this piece. That we know. I'm going to copy it from right there. That is 2C plus 1D. It's 1C minus 1D, and it's 0. And to that, I'm going to add E times V. Well, that's E times 0. That's plus. That's a 0. It's E times 1. So that's 1E. And it's E times 2. That's 2E. Okay. Let's add these two together. I have 2C plus 1D, my first component. My second component is going to be 1C minus 1D plus 1E. My third component is going to be 0 plus 2E. So that's just 2E. And that's my linear combination. And what does this tell me? It tells me that based on the vectors x prime, y prime, and v, they form this linear combination. And all I have to do is change c, d, and e, and I can pick up any vector in R3. So there's two things we need to do. First, we need to graph this picture. Well, first let's write our conclusion. Our conclusion is this. Conclusion. Is if we have three vectors are necessary. 3 vectors are necessary to create all of 3 space, using linear combinations. Using linear combinations. Three vectors, that's it. With just 3, I'm going to use the word different vectors, We're going to talk about what different means soon enough, but 3 different, let's put that. Now, let me kind of hint at what different means. 3 different. If I have 3 different vectors, that's it. With those 3 different vectors and my all possible scalars, I can create or get to any place I need to in all of R3. So, what does it mean to be different? Different means you need to come over our picture. And different means this. Different means that if I had picked, and I use purple on purpose, if I had picked a purple vector, meaning a vector anywhere in my xy plane, right there, what would be the third component of that vector? Well, in this case, it would be that z is 0. In other words, this vector, this purple vector, is a linear combination of x prime and y prime. So this vector is of no needed value because it's already covered by these 2. So when I say the vector needs to be different, it means that it can't be in the plane already created by the first 2 vectors. It needs to be outside of the plane covered by the first 2 vectors. And so in this case, just so the planes were easily visible, we used an obvious plane, the xy plane, and we used a yz plane because that was an easy one to see. But the planes don't have to be those for this to work. And so that's our point today, is that if you have 3 different vectors, you can create all of 3 space. Thanks for watching.